Just a quick introduction about myself. My name is Ankit. I primarily work in designing and building API infrastructure, streaming platforms, and so on. I have had opportunity to work both around engineering aspect and also sorry for that. The engineering and the customer success aspect of it. Okay, so let's get started on the shift left. First, before we dive into shift left, first we have to understand what's actually wrong with the traditional architecture that we follow right now. So even though event-driven system is now a very common topic and has been adopted by a lot of Okay, so first we have to understand what is the need for this shift, right? Because if everything is working fine with the existing architecture, there is of course no need to break down and build something new, which is when there is no need of it. So this is the traditional flow basically for a event-driven system, where you have multiple data source. It can be a Kafka topic, it can be your a prediction or a log that gets generated from the website visits, the application clicks, and so on. It can also be an IoT devices. So all these different source of data or stream of data gets transformed or and then gets stored into a data warehouse or in a bucket or so on. And then from there, all these end user teams, right, which can be, let's say, your report generation, your ML model, it can be even managing your IoT devices and so on. All these that create some sort of insights or actionable input based on the events that got generated. But what's the problem here, right? Like everything is working as we expect. It is event driven and everything. The main thing is the data governance, the security schema enforcement, and so on, the filtering and all that happened towards the end of this life cycle, which is the right side of it. And what happens and what are the problems because of that is, let's say there is a poison pill message or an incorrect schema message that passed through. Now what happens, since the filtering and the governance all happens towards the end of it and are specific to individual consumer applications, even one message can create ripple effect, whereas that can delay the go to production timeline. It can create impact on the prediction that you guys want to generate and so on. It also has implication around regulatory part of it or compliance part of it. So we all want to build application that can be used across globe, but every part of the world, like for example in India, when you launch a product, you launch a website, you launch an application, you should enforce all the regulatory demands of Indian government. Same happens with European Union, same happens with states and so on. So imposing all that shouldn't be like a rework of your entire application, reworking the schemas, the security and all. It all should be an injectable concept where you apply that in the beginning of the data injection, and then all the downstream teams don't have to have that visibility on why there is a change in data, on why there is a certain filtering that has applied. All these can be shielded from them. They don't have to get exposed to this internal workings of it. Again, then there is this team silo concept where the knowledge among the teams are fragmented. Like dev team will have their own assumption, the end user teams have their own assumption and idea around how the data is formatted and so on, and the partner team will have their own assumptions. The reason for that is there is no standard contract that is being followed across. there is no single source of truth that everyone can refer. Okay, for my this event, this should be the schema. That's it. These are the endpoints. These are the security access that needs to be applied. And what happen if all these implications start happening is eroding customer experience. Right, as long as your customer is happy with your product, you don't have to change anything, in my opinion. You don't have to apply new things. So but when all these problems starts coming up, then the first visible impact is your customers are not satisfied, your users are not satisfied with what you have done. So that's where the shift left comes into picture, where we move the governance part in the beginning of the life cycle itself. Now let's understand how Async API enables the shift left. So I'm sure we have already had sessions around the power of Async API, but just to jolt some interesting points, it's diverse protocol support. Like a single spec is capable of supporting HTTP to MQTT, Kafka, and so on, like SSE and all. So you can just use Async API, and irrespective of any use case of event-driven system, you can just enforce that irrespective of the teams and the products. Second is cross-platform governance. So governance in Async API is not an optional concept. It is like, for example, if you have Kafka, you have schema registries and so on. If you have HTTP, then you have your own schema that you have to enforce. But Async API allows you to do all these using the reusable components called schema or security schema and so on. So you can use a single component across different protocols and so on. Third is, since Async API is actually built for the event-driven system, you have all these individual components like server, channels, operations, and all this, because these are the real. These concepts mimic the real, real life event stream or the event flow. And the last and the most important part of it is, our assumption is Async API spec, whenever we discuss about it, is just a way of designing or documenting your APIs. But that is like, as Lucas have mentioned in the morning, is just a byproduct. It's not like the main intention of having a Async API, because to me, I feel if you're just using it for docs, then you're putting so much of more effort that's actually not required there. But using Async API to kind of deploy your entire infrastructure, you just have Async API spec for Kafka and HTTP, and you build out a whole app just using that spec. So next thing that I wanted to discuss is, how do we achieve this in the most easy way and most event native way. So for this discussion, I have taken Zilla, which is an open source event native proxy. Zilla is developed by an organization that I work for, Activity, and so what Zilla does is, Zilla understands Async API completely. It has a first class support for Async API spec, and using multiple specs, like let's say if we have a HTTP spec and if we have a Kafka spec and we pass it to Zilla, this will generate all the endpoints to the end users, which can be your mobile app, which can be an IoT device or anything like that, which is backing with a Kafka cluster. So you get your facility to have a streaming system, whereas without actually have to do the translation, the transfer or migrating from a REST to a streaming system. Now, this is like one of the most interesting aspect of Async API, right? Like, so instead of thinking Async API is like a single entity, we have to think how Async API actually fits into this large picture of API management. And more than API management, the next generation API management, which supports streaming, which supports event-driven applications and so on. So first is the API standard. So as we have already discussed, Async API has support for various protocols. So using just with one contract and one specification, you can define a lot of different use cases which are spent across various protocols. Now you can use an API platform to enforce those contract during the runtime. Then you have centralized governance. Now let's say I have a use case where both MQTT and Kafka is involved, whereas like both IoT and a Kafka cluster is involved. But I want the schema to be consistent irrespective of which protocol or which type of message is flowing in. Now that's where as I mentioned, Async API have this reusable component schema that can be used to leverage and enforce governance across all the events that are flowing through, irrespective of whether it is a MQTT event or whether it is a Kafka event. All these leads to the enhanced developer experience. So now what we have achieved through this is, instead of raw data, right, raw streams, you actually have a API like a real-time data products that you can expose to end users. You can have your teams that can just subscribe to a data product and just start using it, instead of them having to find which topic should I talk to, which endpoint should I talk to, what will be the schema, what will be the request type, what will be the response, and everything. So once we have this standard contract of Async API applied everywhere, it makes life easier for not like just for one team. It can be like we can keep leveraging that and add more use cases with just the limited number of effort that we put in. Now I just wanted to give a quick demo, like just for this presentation. So I've used Async API, Zilla and Kafka, and I've built a stream pay application. So this is basically what you call let's say a phone pay or something like that, just a example of it. So if you look at the directory structure, this is visible, right? You can find two spec. One is Async API HTTP spec and a Kafka spec, and both of these have its own sets of operations, schemas. Where is the schema? Yeah, all the schema, message informations, and so on. It also have the security informations like the JWT token and all, because this is a banking application. We can also add information around security and tokens and access and so on. Now to run Zilla, we need this zilla.yaml file. Here, if you can see, what we can do is actually map HTTP operations to a Kafka operations, so that the translation can happen very easily, and then we can spin up a HTTP Kafka proxy as part of Zilla. Now I think I've already started this. So this is just a Docker compose that I have started. It has components like Kafka, then Zilla. It also have a couple of simulators that gonna trigger dummy events and so on. And this is the very simple UI that we put together for this session. Hold on. Okay, good. So as you can see, these are the events that are flowing in. These are the transaction that's happening. You see the balances getting updated in real time. You see bunch of requests to either pay or to receive the money and so on. And all these information is getting stored in individual Kafka topics. So if we can open up Kafka UI, you can see all these topics, right? Yeah, you can see all these topics that's actually storing the transaction details and balance, user information, and so on. But from a UI perspective, these are just the endpoints. So from UI perspective, just the HTTP spec is more than enough, and Zilla is the one that's tying the thread between the HTTP spec and the Kafka spec, and this entire use case can be deployed with just as ease as you guys can see. So that's a very simple demo. So I think that's pretty much what I have had. In addition to what I've shared already, the information I would like to share some interesting information around the next gen API management plane. So we have identified this gap in the market is the existing API managements are either have repurposed to kind of accommodate streaming use cases which are actually built for REST, or these are just Kafka consoles that are being repurposed as a API management plane. So we have identified this gap, and we are building on this new product that's going to address all that, and we have a launch coming up by end of this month. So if any of you guys are interested, let me know. I'll be happy to let you guys know more around it. So that is it. Thank you.
Thank you so much, Ankit. Does anybody have any questions? Yes, sir.
So is the Zilla.yml or maintained separately from the AsyncAPI.yml, or is generated from the AsyncAPI stack?
So you can have it either way. You can have independent Zilla.yml that kind of helps Zilla. Like you can configure everything that you want for Zilla through Zilla.yml, irrespective of AsyncAPI spec. But if you have AsyncAPI spec, you can just tie down that AsyncAPI spec into the Zilla.yml. You don't have to redefine everything like server information or schemas and so on. So it is independent, but of course, since we have first class support for AsyncAPI, you can just use your spec as it is.
Anybody else who has a question?
Yes. Right now, for the streaming side of it, we only support the Kafka Wire protocol. So anything that uses Kafka Wire protocol like Red Panda, Kafka, Confluent Cloud, and MSKs and so on, at least for the streaming part of it, there's just these. We don't have like a explicit support for RabbitMQ.
All right. Thank you so much. Please give a round of applause for Ankit.